So thank you all for joining us this evening for another talk in our series of technical talks, or tech talks for short. We, in the computer science, cybersecurity, and information systems engineering programs, run about 3 tech talks per year. We're always looking for ideas for topics. Feel free to volunteer yourself or one of your best friends in order to give one of the tech talks if you like. We are also looking at starting another Tech Talk series pertaining to our data science degree program. So if there are topics in that track, feel free to suggest them either to myself or Eleanor Klan, standing up in the back of the room currently. We would love to hear your ideas. This evening, we're very privileged to have Dr. Pat Allen presenting to us. Pat is a retired colonel in the Army Reserves. He has been at APL, the Applied Physics Laboratory, for approximately 9 years now, rising to the position of principal professional staff and working in the areas of network security, information operations, and those particular areas. He has a PhD in operations research. Mm-hmm. And he has written 2 books, one of which I have here, Cloud Computing 101, a primer for project managers. And so he will be talking to us this evening about cloud computing and cloud computing security. So thank you very much.
Thank you. Thanks, Phil. Okay, everything on? Good to go? Testing. All right. So we've got here, I'm going to be giving a very brief overview because cloud computing itself is a big topic and a very rapidly changing topic. And also, I tend to have 2 speeds of briefing, high speed and overdrive. So if I go too fast, just kind of wave and tell me to slow down a bit. So we're going to be covering the types of clouds, and as well as the 3 service models and the 4 deployment models, and also who owns it. Then cover the common security issues and give you some very basics of why MapReduce programming works. So what's a cloud? By the way, IEEE did a survey, and they asked people, does the weather affect how cloud computing? And 51% of people said yes, including my 94-year-old mother. But actually, when you look at what's a cloud, it's usually a big honking building. Doesn't have to be, but you have a big building with lots of electrical power and a lot of cooling. The electrical power, it's like 100 times more electricity per square foot than a normal office building. I mean, this is really a lot of power it sucks down. It also has lots of hard drives and processors, usually of the same make, so they can swap things in and out, they're commodities. Really high performance remote access, so big honking pipes coming in and going out. Lots and lots of virtual machines, depending upon the type of cloud, which I will get into, and may or may not have things like the Hadoop distributed file system or other types, which I will get into also, usually running on the VMs, running on the hard drives, and the green grass grows all around. Now, a cloud doesn't have to be this big. Okay, a cloud does not have to be this big. One of my colleagues built a 7-node cloud that fit in a box about so big. Okay, so cloud is basically how it the things that define how it operates. But usually, because of the economies of scale, bigger is better, and you get more efficiencies. So the 3 types of cloud: you got the storage cloud, which you get for your home and business. Anybody use cloud storage? Lots of folks do. And that's the first type. Basically, stuff goes in and it comes out, and that's all it does. There's no real processing per se. The utility cloud, which is what a lot of people have heard about, is usually compute power as a service. And there's 3 types of that. You have the infrastructure as a service, and I'll get into more details later, the platforms as a service, and software as a service, and these are what are called service models. And then the data-focused cloud uses things like Hadoop distributed file system. There's another version that Google has, which was first, but it also allows you to run parallel processing, big parallel processing. And so you have these 3 types, and then you have the service models, and we'll get into the deployment models and to the ownership later. But any one of these, you can either build your own or use a third party. Now, one of the advantages, remember, economies of scale help, so bigger is better. That's why a lot of people aren't building their own clouds, and they're going and using clouds like the AWS, Amazon Web Services, or Azure from Microsoft, or IBM. Everybody in there's a lot of the big players in there. And because the economies of scale are so good, fewer people are building their own private clouds now. Okay, so kind of a summary of what I had presented already. You've got your storage cloud, which has lots of memory, and it's not computing squat. You know, life is like a sewer. You get out of it what you put into it. That's where the storage cloud is. You know, you put stuff into it. That's what you get back out. Then you have the utility cloud, which is not only lots of memory, but you usually have a bunch of virtual machines. There's a lot of processors, a lot of horsepower, a lot of computation. And then the type 3, the data focus cloud, has lots of memory and then some sort of distributed file system, in this case Hadoop, and then you can run your MapReduce programs, do your parallel processing. Now, I call it data focus cloud as opposed to data cloud because you got data in the first one, you got data in the second one, you got data in the third one, right? So that's why I call it data focus cloud. The focus on the third type of cloud is to process data usually in parallel. Okay. And I'll give an example of that later. Okay, so storage type 1, it's type 1 cloud, it's storage cloud. You got huge amounts of memory that people can throw their stuff into. You know, people put their photographs in there, music, videos, electronics, books, scanned papers. And most of them all have this automatic replication. And why is that? Well, if you put all your photographs and your family into the cloud and they lose it, that's not so good, okay? So what they usually do is they have a replication method. Hadoop, for example, HDFS, makes 2 more copies of it. So you always have 3 copies. And it monitors those copies. If one of the copies disappears, it goes, and it creates another one, okay? So it is very difficult to have circumstances in which all 3 will disappear at once, okay? Because frequently they put 2 locally in the same building and the third one's in another building somewhere, right? So it gives you a pretty good way of storing it. And you know, look at all the people who lost stuff in the floods, okay? For those who had stuff on the cloud somewhere else that didn't get flooded, that was a good way to store it. But you can't run your Office apps in the cloud. You can't run parallel processing. It is what you get out of it, what you put into it. So it is a place to store information. Now the type 2 clouds, this is the ones where you got your compute power. So you got a lot of VMs. Everybody here know what virtual machines are? Good. Okay. Yeah. When I first started doing these presentations 4 years ago, I had to include what virtual machines were. Okay. But you have different types of flavors of virtual machines, and you can usually pick and choose because almost every web cloud service provider has a web page that says pick and choose what you're looking for. Here's the price. Here's what it's going to cost, etc. And then what it allows is for the cloud service provider to create and destroy VMs on demand. So you have, if you don't need anything, you're not paying for them. If you suddenly say, oh, I need 100 VMs, they bring up the 100 VMs, they let you use it, you're done with it. You only pay for it for the time that you have those VMs up. So it's very efficient. And then, of course, they rent it out to other people, and then they rent it out to other people. So they get a lot of mileage in terms of getting paid for these VMs they put up, but it's to different users over time, which can create a security problem, which is one of the security topics I'll be getting into later. And also it gives the cloud service providers easier maintenance. So if you've got a patch, they've got a gold standard copy of the VM they want to put out there. They patch that one, and then every time they spin up a VM based on that image, then everything looks the same, okay? So it's very easy to keep things patched when you have the cloud environment. And there are, as I said, the 3 service models, and I've got a slide on each one of these coming up for the infrastructure as a service platform and software as a service. Still, I'm doing okay in terms of speed? Okay, good. I want to make sure. All right, so for the infrastructure as a service, you know, it's like your enterprise replicated in the cloud. So if you've got a bunch of machines, you can actually put your machines onto the cloud. So you can have your desktops up there, you can have some of your data servers up there, you can do a bunch of different things that you want to do. The things you would normally do in your enterprise can now be done in the cloud. And for a startup company, for example, that doesn't want to spend a huge bunch of bucks on IT infrastructure, they can rent space within the cloud. And then as they grow, they rent more space in the cloud. Okay? And so the second one, the platform as a service, this is mostly a more specialized development platform. For example, Google Apps. Development tools for applications can be fairly expensive. So what Google Apps did is said, okay, we will put the apps on a cloud, and everybody who wants to develop apps comes to this platform, and they don't have to buy all of the hardware and all of the software associated with running that environment. They can develop within the environment that Google provides. And so Google was one of them. There was forgot the name, but anyway, there are several platform as a service providers, and then people would then come in and develop apps on it, and they would only be paying for the access. And sometimes it wasn't so much paying for the access; it was they would get a cut on when the apps were actually sold. And then you have the software as a service, which is a lot more, even more specialized. There's particular software that is being accessed remotely. One of the biggest is Salesforce, if everybody's familiar with that. Salesforce has gotten very large because they really did very well in this niche. And they started out saying, hey, all your salespeople, wherever they are in the country, wherever they are in the world, can all log into the cloud, and this will be the place where it's all done. Okay? So it collects all the information, you can monitor it, you can see what's going on, and it gave a lot of visibility to the management they didn't have before for their sales forces that were distributed all over the country or all over the world. This was also used quite a bit for disaster relief. So people put together software packages for disaster relief, like in Haiti and so on, and said, okay, here's where the needs are, here we found these survivors, here are people saying they're looking for their families, et cetera, et cetera. And so it became one application for software as a service were these websites that people could go to these databases online and find relatives, find who needed help, find who could provide help. And so then there's variants on these three. It's not really a new category. What it is each of these has some variants. And so desktop as a service is one of the variants. So if you, again, don't want to spend a lot for your own desktops, you basically go to a desktop as a service. They will provide you a desktop of a particular type, Windows, whatever, Linux, whatever, and you go ahead and use that. And so you're renting the desktop. You're not providing your own licenses. They basically wrap up the cost of the license for what you're using within the fee that you're paying. And they also have a database as a service, which is you can access a very large database, put your data in, use it without having these huge license fees that some of these databases have. There was another one, business process as a service. So you could monitor your business process and model your business processes and have people go to these. So each one of these has different variants, and there seem to be new variants popping up over time, depending upon what people, when they find a niche, say, oh, I can offer this. Okay. Any questions so far before we go into the Type 3 cloud? Once, twice? Okay. Now, the Type 3 cloud, I'm going to do a little terminology here. Let's start at the bottom of this. Remember the first picture had hard drives and memory, and we got operating systems. Well, remember I mentioned there was HDFS, Hadoop Distributed File System. Google has their own version, which was actually first called GFS, the Google File System. And then they had their MapReduce programs, which allowed them to run parallel programs. And Hadoop also has their MapReduce program. So Apache Hadoop now has several components. This is why it's under Apache. And then their structured data format is a Cumulo, and Google's is Big Table. So if you're hearing about what Google is doing versus Apache, what's a Cumulo versus Big Table, this is your translation chart. This is your cheat sheet for telling what is where. We're going to be focusing on the left-hand side just because it's easier rather than jumping back and forth. So for the Type 3 Data Focus Cloud, it usually runs on bare metal hardware. Originally, they tried it where you would have the Type 2 cloud with the virtual machines, and then they put the distributed processing on that. And it was slower working on the virtual machines than working on the bare metal. So you got the processors and things of that nature. So they wiped out the virtual machines and just put the HDFS on the bare metal, and then they started crunching away. And so most of the type data-focused clouds now are straight onto the bare metal with their distributed file system that's working. Okay? And then it handles all the bookkeeping of where the data is stored and allows for the parallel processing. It also does the replication for you. So Hadoop, if you're interested in the details of Hadoop, the book Hadoop, The Definitive Guide by White is very good, and it describes how this central part of the Hadoop HDFS system looks around and says, oh, we've placed this data here, we need to make 2 more copies, bloop, bloop, and it makes the other 2 copies, and then it monitors and makes sure you always have those 3 copies, as I mentioned. So it gives you a lot of good security in terms of it won't be lost by accident. And we're talking about huge data. We're talking about petabytes or larger amount of data. They're now getting up to exabytes. Petabytes is what, 15 zeros after it? I can't remember which one is 15 zeros. I think petabytes is 15 zeros. So there's 1 with 15 zeros after it. Petabyte is not a pet that bites you. Okay? Yeah, but it's huge amounts of data. And relational databases traditionally did not even have addressing schemes to allow petabyte amounts of data. Okay? If you put it into an old relational database, it would blow off if you tried to put a petabyte of data. And I was talking with a sponsor one time. We said, why can't they fit all this? Because you blew off their records. So then the relational database, this was the traditional format. Think rows and columns like a spreadsheet. Okay, and I'll give you an example coming up of how you then translate from the traditional relational database into the data structures that are used in the cloud. They don't use relational databases in the cloud, but the good news is you can translate your relational databases into the cloud format fairly easily. And then they also have structured non-relational databases. And I'll give you an example of this coming up as well. You've got Cumulo and Hbase. It has its own structure, and it makes it very easy to then run the parallel programs. Okay? And then you have unstructured databases. And here's one of the big advantages of the cloud. If you got text files, web files, binaries, they're all stored in HDFS, you can still run processes on them. You can still run programs on them, okay? So you can go in and look for all the relationships between things. For example, a census database, you can go in and find out all sorts of combinations of things, and it'll find it for you. And it can be in any unstructured format. It looks for what they call key value pairs. If I got time, I'll get into that at the end. Looks like I will have time. Going fast enough.
Question.
Sure.
Is MongoDB an example of a structured non-relational?
It's non-relational. It is. I don't know how structured. I know it basically is formatted for the key value pairs itself. I don't know if it counts as structured. Do you remember? I know it's not relational, but I'll give you an example of RDF, which is very close to what Mongo does. Okay, but Mongo was basically set up to be able to do cloud type processing. Okay, let's see. Anything else on that? Going once, going twice. Okay. All right. So the Type 3 cloud. If you have structured tables in the clouds, they take those disparate types of data and places them in some sort of format. And so originally you had triple store, which was the resource data format, which I'll give you an example coming up. And then the big tables had a 5-tuple store, and I'll give you the details of that. And then the 6-table store for a Cumulo. If you already have a legacy relational database and you want to put it in the cloud, you put it in the table format. Okay, because you could throw it into an unstructured amount, but why bother? You already got the relationships already defined. You might as well retain those relationships when you put it into a cloud format. And you can also, as I said, run MapReduce programs against unstructured data, and then you can put the output into a table, or you can put the output into an unstructured data file, or you can put it actually in an old relational database if you really want to. Sometimes I'll have programs run that I put out into a Excel file just because I've processed down the huge data down to something I can manage, and then I just use Excel on it. So you got different options, which was my last example. Okay. So here's an example of what you can do with cloud. So the current technology, you got structured database, which is legacy relational database, and unstructured, which is legacy non-database, like web, binary, text, et cetera. And going into the cloud, you can take the structured database and put it into tables like in Hadoop or like, for example, Accumulo. And you can do what's called a single tablet query, technical term, but basically says it's like your old queries, but it's on an Accumulo table, right? And then you can put it out to legacy applications. Or from there, you can run a MapReduce program on Accumulo and put it back into Accumulo. Or you can put the output into a legacy application. And then if you have your unstructured data, you can then run the Hadoop distributed file system, put in the Hadoop distributed file system, run a MapReduce program, put it back in there, put it into structured with Accumulo, or put out legacy applications. Gives you a lot of flexibility. Okay? So you can go from structured to unstructured if you want, but more usually you go from unstructured to structured, and you do these processes. Okay? All right, so some of the advantages is you can ingest data from the legacy relational database, and it's fairly easy. You can actually program it in. The biggest problem you usually find is what they call disambiguation. Is John Smith from this data file the same as John Smith as another data file? You have that in the real world anyway, so, but that's where they sometimes run into problems. And you can map, as I said, in the cloud format. You can ingest new types of data without having to change your data structure. So if you had the old relational database with rows and columns, and let's say you now add a new type of data where you have to add new rows and new columns, okay? When you add the new columns, you now have to back populate or leave blank the previous rows that you had, right? And so you're changing your data structure, which means any queries you had, you may have to change to map to that. With the cloud, it doesn't matter, okay? And I'll give you an example of that coming up, is the fact that you can add new types of data and it doesn't have the overhead of the rows and columns. And so I will show how that works. And again, you can process huge amounts of data in parallel through MapReduce programs. And the reason is the data is stored in these different locations. The MapReduce programs are relatively small, and they all know it's going to be in some sort of format, either RDF or Accumulo or Hbase. And then they throw the programs to where the data is, and they run the programs, and then the results come back to the place where it was sent from. And so rather than move the data to where your program is, they're moving the program to where the data is, get the results, and bring it on back. And that's one of the big efficiencies of cloud computing. Also, it allows for solving problems of finding relationships that are previously not feasible or efficient. Bakery sales and weather. What they looked at was that no bakery wants to bake a lot of stuff that they're not going to sell. They got to throw it out. Big waste. So they did some analysis using cloud computing and found that on rainy days, people are more likely to eat chocolate-type things like cake. Big surprise, comfort food. And then on sunny days, they're more likely to have sandwiches, paninis, and things of that nature, okay? So by then combining with the weather forecast, they could tell the bakeries, hi, why don't you bake more of these and fewer of those because you're more likely to have less to throw away, okay? Not previously very easily calculated. Now, logically, you say, yeah, but how much? Okay, and so by running the previous numbers, they could then crank it through the cloud computing and make recommendations to the bakeries that would subscribe to that service. Also, it doesn't require a huge parallel processing machine. Does anybody remember high-performance computing machines, right? Big honking things, very specialized, had to rewrite your stuff into the language of that machine, so it would do the parallel processing, do the load balancing, and maybe you get the answer you're looking for after 4 or 5 tries, okay? Today, they run on commodity hardware, and it handles all that bookkeeping for you. You don't have to worry about load balancing. It does it for you. And you don't have to worry about where the data is located. It keeps track of it for you, okay? So a lot of the overhead associated with traditional parallel processing has just been resolved by the cloud computing. And that's one of the big advantages. It became parallel processing for the masses, okay? Because instead of having to have access not only to the particular high-performance computing facility, you had to have knowledge on how to rewrite your programs into parallel processing and do the load balancing and figure out where the data was. Any other questions before I go on the next one? Okay, so to summarize what we got so far is you got the 3 types of cloud, and you also have your 3 service models, IaaS, PaaS, and SaaS. And as you're going from here to here, this is the most general, most flexible. This is the most specific and least flexible. You basically get a program that you can run here, but run it from anywhere. You get the ability to replicate your enterprise and do what you want with it. And then in between is the platform as a service. Okay? So from here, we're now going to look at deployment models. Okay? So you got types of cloud, service models. We're now looking at deployment models. And it comes from NIST. And they're talking about, first off, a public cloud, like AWS, like Azure, et cetera. Anybody can use it. You may want to get a virtual private cloud, i.e. only you get to use the part, or you can use what everybody else is using. Okay? The private cloud is exclusive to one party. So either you build your own, and then you get to play with it yourself, or you may be a virtual private cloud provided by the cloud service provider. And they say, yes, we will guarantee for a price, you only get these sole access to these VMs or hardware. Community cloud, it's exclusive use by a community group of folks who get together. So it's kind of in between the public and the private cloud. And then the hybrid cloud is 2 or more of the above. So any combination of those 2 or all 3 of them is a hybrid cloud. So for example, if we store a bunch of archives, say APL stores a bunch of archives, and if we store it in the cloud, then we may have a hybrid situation where we store some things locally and store some things remotely, okay, in the cloud. And there are a lot of offerings from the cloud service providers about hybrid clouds and how to make sure they can seamlessly interact. They try to make it look as much as possible like it's still local to you when it's actually remote. So now we put it all together. So we got the cloud types, 1, 2, and 3. We got the service models, which are only variants on the cloud type 2, the utility models, clouds. You have your variants off of the IaaS, PaaS. You have your deployment model, which is private, community, public, or some hybrid. And then you have the owner. It's either in-house or third party. Okay? Now, the advantage of a picture like this is, besides it being nice one over the world, telling you where everything is, if I am a user and I want to use the cloud, I say, oh, I need one of these, and one of those, and one of these. Okay? And the cloud service provider says, we can provide one of these, one of those, one of these. Okay? So it gives you the one over the world picture of what it is you want to do. You may want to have some of your stuff in-house, some of the stuff with the cloud service provider, third party. Okay? So it gives you a good way to picture the combination of things that are possible with the cloud with you.
Quick question.
Sure.
Do you have any sense of the costs associated with that?
Yeah. Those are some of the.
Will you please repeat questions for?
Oh, I'm sorry. So can I provide some of the some estimate of the cost of these things? Of the overlay. Well, each of the elements has their own cost. For example, if the third party is selling you storage space, okay, then they will have, they'll probably be in the public part, but you will then pay them for the storage, and storage is relatively cheap. If it's private, you're going to pay a little bit more for the private part. Community, probably around the same as private, because you're basically limiting the number of people who have access. Okay, and then depending upon the IaaS, the relative costs are a function of how many VMs you use, okay, and the size and the speed. For example, a couple of years ago, Amazon Web Services, it went anywhere from free for slow VMs to screaming fast ones at $4 an hour, okay? And so, you know, this is the sort of stuff, that's kind of the range that it would be looking at, okay? And, all right, any other questions? Yeah. Okay, so some additional services. I just picked Amazon Web Services, and there's the link if you want to look at. Lambda, it's code run in response to events. So if you have something that's monitoring things in the cloud and you want to process what is going on in the cloud, then you can use Lambda to make those calculations and then take an action. Okay? So it comes very handy for those who are working on cloud security. Amazon RDS, the Relational Database Service, they offer things like MySQL, PostgreSQL, Oracle SQL Server, Maria Database, and so they've got a lot of different relational databases that you can use. Remember I mentioned that database as a service? Well, this is the type of thing you could look at. They've got a whole bunch of different storage options. They use Glacier and Snow series, Snowball, Snow thing, right? The reason is you're not going for speed, okay? This is because you want to, basically they're not expecting a lot of changes quickly, okay? You're going to put stuff in and eventually you might want to go access something, but you blow off the dust first before you do it. They got Amazon Dynamo database. It's a NoSQL database and it's managed. Amazon Aurora, it's a high-performance managed remote database. You got migration services. Remember I mentioned that it's relatively easy to go from a non-cloud database to a cloud database. They've got it set up that you can pull in exabytes of data. Okay, you were talking about big honking pipes, and it's going to take a while. But once you get it up there, it's there. And now you can do stuff with it you couldn't do before. Okay, so that's one of the big advantages. Amazon Web Service network and content delivery including a scalable domain name service, security, identity, and compliance tools, because cloud security is a current concern for a lot of folks, and a good example of some cloud security issues coming up. Analytics, they've got EMR and Hadoop, they got Athena for SQL, they got streaming analytics, they got deep learning, machine intelligence, and desktop and browser streaming. So these are, and this is a subset of what just AWS is providing. You can also, Azure has got a whole bunch of their services, IBM's got their services, there's a whole bunch of, check with the different cloud service providers, shop around, okay, and look at the different ones. I just used this one as an example. Okay, before I get into cloud security issues, any other questions yet? Because I'm doing fine on time. Excellent. Okay. So, cloud security concerns. I'm just going to do some of the more common ones and the ones that people were originally concerned about. Physical access and location security. It's no longer on your premises, okay? You can have guns, dogs, and gates, and you don't have control where it is, okay? And so that's one of the issues. Communication security. If you're communicating with the cloud, it better be encrypted. And then you have shared use vulnerabilities. Like I said, if you're on a VM on a given machine and somebody else is there on a public cloud, is there some sort of risk there? And there are a couple I couldn't show you. And then some of the solutions, you got limited access clouds. I mentioned the virtual private cloud. I'll get into more details there. Good hygiene and encryption. If you're involved with the government's FedRAMP, the government cloud authorization group accreditation. And then I'll go into the what they call the 7 deadly sins, the common customer errors for third-party clouds. Okay, so the physical security is one of the big things. This cloud service provider is storing it somewhere not where you are. And so one of the problems that arose fairly early was I don't have a power failure. Where the cloud has a power failure. What's their responsibility to me if I've got a service agreement with them? And Amazon came up with, oh, we'll give you credit. Okay, that's it. We're not going to pay you. We'll just give you credit for using us some more. Okay, and so it's dependent upon how much of a service level they have. So if you're within 99%, that's great. If within 95%, you get more credit. If it's less than that, you get some more credit. But they avoided all the legal issues by their service level agreement. Was we don't pay you back. You get a chance to get some more time with us, okay? And they're not the only ones doing it that way. I mean, basically, most of the cloud service providers have different locations. They just transfer the stuff on over. What was it? Sandy, Hurricane Sandy. they were shifting as much as they could from one data center. I don't know who they were, but this one CSP was moving everything from one data center to a different region. What wasn't going to get hit by Sandy. Okay, so they could then maintain the services. You don't necessarily control the geographical location of the data. Early on, the data you put in could go to China, India, anywhere. Okay, because that's where the data was going to get stored. Then some of the cloud service providers listened to their customers and said, we really are a little concerned about where you put this stuff. And so they have regional data centers. And so for price, you can keep your data within certain regions. Okay, and Europe was also very interested in doing that as well.
You can also make a comment, you can limit who works in those facilities as well.
The comment was you can also limit who works in those facilities as well. And one of the selling points that, depending upon the type of market they're trying to address, the cloud service provider will have certain limits on who works there and has access to what. One of the things, for example, is good physical security is everything is automated. And if you have, say, an electrical closet, if a person tries to enter an electrical closet without an authorized work order, the alarms go off. Okay, so they're very a lot of folks are very concerned about the security of the physical location. And if you automate enough, I mean, like Amazon Web Services, they've got like 24 people in a huge honking building. Okay, that's all they need to run it because so much has been automated. Let's see. As I said, you need secure communications to and from the cloud. If you have a password that you're using for your cloud, the cloud service provider doesn't have that password. You lose that password, you might as well get rid of that and start over. Okay? So if you want to make sure it's really secure, you do your own encryption. Now, some of the cloud service providers provide encryption for you, but that means they also have the key to decrypt it. Now, you may want that. If you are just Joe Schmo who wants to store my photographs in the cloud and I want them encrypted so some hacker doesn't get in and put them on the web, then having the encryption provided by the cloud service provider is a viable option. If, however, you got something a lot more sensitive, you may be concerned about sharing the encryption key with the cloud service provider. You need access control and authentication for your users. And some of that access control really should be multi-factor authentication. There was one cloud company that had only username and password. They got hacked, they got ransomware, and they got hosed, and they went out of business. And so, you have to be very, very careful about that. Let's see, like I said, somebody else runs the hardware you're running on, as well as some other people are running on the hardware you're running on, which I will get into that coming up. And then since other customers share the same CSPs, if somebody's doing a denial of service attack against somebody they don't like, and you happen to be on the same stuff, your pipes could be affected as well. Your data rate could be affected as well. I haven't seen much of that, but it is possible. And then there's new vulnerabilities for the virtual environment. I think it was Amazon Web Services. There was a Zen flaw in the Zen hypervisor, and they had to take down about 10% of their machines that were running on that in order to repatch them. And so that created a little bit of a kerfuffle, but they did it and it's resolved, and so they can do it. Like I said, having the central ability to patch is important. See, one of the things is you can patch it when it goes down, but if somebody keeps a perpetual machine going, sooner or later you have to get to a point where you can bring it down so you can put the patches in. Okay, so here's what the cloud service provider responsibilities are. They've got firewalls to help secure their own perimeter. They've got IDS and IPS to monitor activities within the infrastructure. And they capture and review system logs and access logs because they want to make sure nobody's getting in to their control centers and things of that nature. Like I said, the admins are going to use multi-factor authentication for both local and remote access. And then you got rigorous change control processes. You exercise least privilege, document your policies and procedures, pass risk complexity. It is just amazing how many weak passwords are used in this world. I mean, everybody sees Spaceballs. You know, remember the combination for the planetary defense system, 1, 2, 3, 4, 5, 6. You think that's a joke? There are some default passwords that are just like that, and you can find some IoT devices that it's that bad. So yeah, it's really important to have good password complexity and enforcement. So the customers also got their own responsibilities. So the previous slide was for the provider's responsibilities. This is for the customer. They have to encrypt their data communications to and from the third-party cloud, right? So you want to make sure that you're not sending stuff in the clear because people listen in, okay? It's the internet. And then firewalls that secure the virtual environment may be managed by the CSP, but if not, then you're going to have to manage them. So if you've got your own data centers and your own firewalls within your chunk of the cloud, then you better monitor them. Customers set their own admin policies, password complexity, how often you change passwords, user audits. And then the utility cloud, they should monitor the actual use. If you're getting a bill that said you used 400 VMs and you only think you did 30, you really ought to have a way to monitor and say, yeah, somebody cranked up another 300 and some odd that I didn't know about, okay? And who has the authority to crank up more machines on your VPC is one of the things that you should be monitoring. Right. So some of the things, physical security, how is physical access controlled? Are there controls on, like I said, the door locks on the electrical closet? Who gets access to the building? Where is your data physically located? And then I'm going to go in more detail on this for all three of these. Communications to and from are secured by you, not the party vendor, third-party vendor, and then shared vulnerability. I'm going to talk about, very briefly, code residency snooping attacks, recoverable data deletion, and distributed denial of service attacks. So the physical security issues, they're responsible for the cloud's physical security. And there are some places that won't even allow tours of their sites. Why? They don't want their site locations known by anybody. Okay? That's part of their security plan. Okay? And so you may not need a tour to get, the service level agreement is sufficient. Say, yeah, I believe you, this is good. The CSP is also responsible for who gets access where. Like I said, they got locks, perimeter controls, CCTV, redundant power, full-time surveillance of key areas. So if they can tell you, yeah, we have these things, great. If it's in somebody's garage, not that they could fit it in the garage, but if it's in somebody's garage, then you might want to be concerned. They also control the physical location, but you can do guarantees on the geographical regions. So like I said, AWS has regional data centers, and they're not the only ones. Lots of folks now have regional data centers because people are concerned about things being elsewhere out of the country, out of their country. All right, co-residency attack. What this is, if your users are on the same VM, and their VM is on the same machine as somebody else's VM, okay? So you are sharing the same hardware, but your calculations are different than the other person's. And it's a noisy environment, but it is actually possible for somebody to monitor you next to them on the same machine, if it's not a virtual private cloud, and to figure out things like your encryption key. And then they got the keys, no kidding, to the kingdom, right? And so you can go to the link here. They provide access to your comms, but basically it's called a side channel attack. Now, there is also some software done by some researchers called Home Alone, right? And it uses its own side channel attack mechanism to see if you're the only one you're the only VM on that hardware. And so if you have made an agreement that is going to be a virtual private cloud, you can guarantee you are the only one on that hardware because you're doing a side channel attack on the same machine and nobody else is there, you're guaranteed that nobody else is there, okay? So there's things that you can use to do that. The other thing is use a virtual private cloud. And then you don't have so much of a problem of anybody else being with you at the same time. The only other concern is the fact that if you're constantly adding or subtracting machines, you may be adding a machine that somebody else has just been on, or you're dropping off from a machine a machine that now somebody else can be on. And I'll give you an example of what that can be a problem. It's not a problem from side channel attack because you're not active at the same time. But if you've just dropped off a machine, that memory is still there somewhere. And that's coming up to the third point. Okay, how does data get deleted in the cloud? For unstructured data, whole files are overwritten. It is 40 times faster to rewrite a whole block of data, which is like 360 some odd megabytes, than it is to search for something, change it, and then come out of it. Okay? So 40 times faster, just rewrite the whole thing. Right? And so the files can be stored in directories, and even whole directories can be deleted. So I say, oh, I don't need anything from this date previously. So it makes it very efficient for making changes and for keeping things up to date. Now in structured tables, new tables are created, the old table can be deleted or accumulates what they call iterators, and they display only the most recent version, or compactors, which actually squishes the data down. I won't be able to get into the details of that for the time being here. And to ensure data deletion, you want to make sure it is not accessible to somebody after you have deleted it. So if I delete my data and release the machine, it may still be in memory. So one of the best ways around that is to encrypt your data at rest. So even if somebody else says, oh, I got a machine, let me see if somebody had left some data on this thing, and it's encrypted, it'll be a lot harder for them to do anything. Okay? So encrypting your data at rest is important. And also, if they say, yeah, we guarantee deletion, it's something you can test. Different cloud service providers allow you to hack your own VPC to confirm what's going on. They don't allow you to hack somebody else's VPC, but they allow you to hack your own VPC, so you can do your own pen testing. And then distributed denial of service. Again, I haven't seen a case of this yet, but if somebody is going after somebody else in the same cloud you're at, then their pipes can get pretty well clogged. Okay, so that might affect what you're doing. So check the service level agreement in terms of how they protect against that. All right, so some of the solutions. One of the things is if they allow you to check the physical security, go visit the site. Usually the best solution is a virtual private cloud. It gives you a lot of flexibility, things you don't have to worry about, and include your encrypting at rest. Use regional support centers when you get a chance. Use two-factor authentication or multi-factor authentication. Make sure that username and password is not the only thing they need to get to your cloud. And then physical access should be restricted. And if you're a government person, then GovCloud or FedRAMP certified, not certified, what is it, authenticated, authorized? Got the word, there's a key word. Okay, 7 most common cloud customer errors. And this is courtesy of Dell Cloud Service Security Consultant. 1, not maintaining your own firewall. So if you've got your own firewalls within your virtual private cloud, you got a problem. And you may shut down unneeded ports. When they found a customer's breach, more often than not, it was any to any, meaning it's wide open. So they just put up the firewall with the default, and anybody could get in. So anybody did get in. Second one, failure to establish and enforce good password policies, because most of the attacks are SSH or RDP, remote data process. The brute force login attacks, they get thousands of attacks per day. So people are constantly trying to break into clouds, okay? And in order to protect that, you got to block them quickly, because otherwise they're going to find the weak password. And what's the odds of you having at least one user who's got a weak password on your system? Probably pretty good. And even if you have the ability to detect and block sustained attack, if they're using a huge distributed botnet type of attack trying to do this, they're going to get through eventually. So that's why you have to take care of the weak passwords and have multi-factor authentication. Of the rest of the 7 deadly sins, third, failure to install, run, and patch anti-malware software on the host-based firewalls. So you've got your firewalls in the, on the hosts in the cloud, and they get compromised because they weren't running any anti-malware on their host. So their machines were wide open. Once somebody got in, they got in. They got all of it. Failure to install operating system and application patches, failure to monitor perimeter firewall for inbound attacks or outbound exfiltration, failure to monitor host-based security controls for signs of compromise, and failure to educate users on following good practices. Watch out for suspicious emails. If you're on your host here and you're logged into the cloud and you click on that email and they get keystroke logging on your computer, they get access to your cloud too. Okay, so you got to be careful of those things. All right. So now, any questions before I get into how MapReduce works? All righty. This is a relational database. As you can tell, this is completely, guaranteed realistic data. Fred Flintstone, Tony the Tiger, et cetera, et cetera. And you got name, you got a column for the name, a column for the address, column for the age, column for the height, and you're going to do a query, find the names of those of more than 25 years old but under 60 and more than 5 feet tall. Okay, and so that's what you get, the ones in blue. Right? So that's a relational database, rows and columns. Now, if you do a triple store, they form what they call subject, predicate, object. That doesn't mean that much, but I'll show you how to map one to the other to get the RDF. And it also used frequently for graph analysis. But you can translate legacy relational database into triple store format, and that's an easy way to place the structured data from your relational database into a cloud format. So what they do is they then stretch it out into this could be infinitely long list. And so your subject is your first data element, and the name, remember, that was the first column, and that's the value. Okay? Then you have the age, that was the second column, and then there's the value. And there's the third column, there's the value. So it's a relatively easy translation from any relational database into an RDF triple store format. And so here's the mapping. There's John Smith, Washington, D.C., et cetera. Now, the advantage of this is, there are several advantages, but one of the things is not only can this thing be very long, but notice it always has the same format. So when you send the MapReduce programs, it always knows it's the same format at the other end. All right? So furthermore, you can add separate disparate databases that don't have the same rows and columns, and it doesn't matter because you just map it the same way. You put its column, name, and the value in the, right? So you just keep following the same. So it doesn't matter if you're using this relational data format or a different one. You just follow the same procedure. Map it in the triple store. Now, besides the triple store, there's also the Hbase Big Tables, which have a 5 store, and this is a cumulo, which has basically 6 elements. And the 6 elements are the ID, they had a column family, they had a column family qualifier, column qualifier, then they had a time, April 30th, anybody born April 31st? Be a good trick since there's no April 31st, right? And then they had a security label, and then it was the value. And so in a cumulo, they always have this format, and then it can be infinitely long, et cetera, et cetera. And so it gives you a chance to have a way to have the structured data that you can say, oh, so-and-so is not authorized access PII data. They never see this. Okay? Oh, I want to reduce my data from this date forward to anything prior to this. It's easy because of the timestamp. Okay? So that's some of the advantages of the structured data. So it's so powerful because you can ingest data from any format, from any data source, as long as you put it into 3 columns or 4 or 5 or 6, depending upon which one you're using. And it defines the attribute between the subject and the value. You just keep adding rows, and you never have to restructure it because it knows what it is. It has the column name, it has its attribute, and it has the value. Okay? And so you can run queries as before, so it's backward compatible. And both old and new queries can take advantage of the newly added rows. And queries can be run in parallel simultaneously on all the servers that you store the data. So this is one of the advantages of why cloud computing is so good for parallel processing. And 5 more minutes to go. And here's an example. You've got, let's say this was trying to find for each URL, find all the pages that point to it. Now, it's real easy if you're on a page to know what it points to. But it's not that easy to figure out what points to it. Okay? So in order to do that, what you first have to do is you take the first page and you find all of its targets and you list out its key value pair of this target is pointing to that, that's target, this URL that points to that target. And then it sorts everything for you, and then you compile the list. So this is a list of the target URLs for A, B, C. So what it does, it goes through and says, I'm on this page, here's the list of all the things I'm looking at. And here I'm on this page, here's all the things I'm looking at. Then it goes over here, sorts all of those, okay, into which ones come first. And now you know who pointed to it, okay, because it had stored with it the same thing. So basically you're doing a reverse of what you did originally, and then you now have your list of those things that pointed to it. This idea of you make one calculation with key value pairs, flip it over, and do the other sorting is very common for MapReduce programs, but that's the principle upon which it works, okay? And so 2 more slides, or actually 3. Back in 2015, there were a survey done from RightScale of 930 IT professionals. They said 93% respondents even then said they use clouds. Okay, and that was back in 2015. I think it's higher now. 82% use hybrid clouds, which kind of makes sense because they use combinations. The private cloud adoption rate was flat, 33%, while the others were rising. Why? People were finding out building your own clouds was pretty darn expensive. Okay, if you got the costs, you've got the economies of scale, it's going to be cheaper to pay for somebody else to do it, assuming the security is what you want it to be. 13% or more ran more than 1,000 VMs, 22% more than 2,000 VMs, 88 were adopting public clouds, 63 adopting private clouds, and 58% were using both, which gets to the thing. So you can see even back in 2015, the rate was going up. And here's my advertisement. For those of you who are present, you got the little flyer that's got it. I would have brought books to bring myself for this, except I don't have a mechanism to pay Maryland state tax. So that's what we can get. But anyway, that almost everything, all but one slide, all the information from all but one slide is in here. The one that isn't in the book, because it came after the book was published, is the Amazon Web Services products, the services they provide. But I gave you the URL for that here, so you got it. And that's me. So any questions? Oh, look, it's 28 after.
Very interesting.
Can I pass you the mic, please?
Oh.
Very interesting talk. Now, I have a question. Imagine I'm a CEO of a company and I hire you to determine whether I should have a cloud.
Mm-hmm.
Okay? You do the analysis and you tell me, no, I don't think you should get a cloud.
Mm-hmm.
Okay? And then I turn to you and say, I want the truth. And would your response be, you can't handle the truth?
No, there have been cases where folks have, and this is from people I've talked to in class as well as my own experience, who have said the customer wants a cloud. They don't understand it. They don't know what it does for them. They don't know it. But everybody else has got a cloud. We need a cloud. Okay? And so the best you can do in a case like that is to help them figure out the one that is going to do them the best good or the least harm. For most of them, that would probably be a storage cloud. Very inexpensive. You can say, hey, boss, you want a cloud? Got a storage cloud for you. You can put all your company archives on this place, and then we'll encrypt it, et cetera, and so on. That would probably work. If they're bound and determined to have a cloud, they probably don't know the 3 different types in the first place. Okay, so you can help guide them to the one that's going to do them the most good or the least damage.
Do you have a way of quantifying your response to them, saying, here are the numbers that indicate the risk associated with you getting a cloud far outweighs the risk of you maintaining your current setup?
Oh, let's see. Risk is a little harder to quantify, but it is one of the things that's important to do. I think what you could do is explain to them that in order to sufficiently secure, even if you're using a storage cloud, the encrypted communications to and from. The cost of the storage is practically nil, but if you want to encrypt it going in, encrypt it in the communications, encrypt it at rest, that will have a cost. And say, okay, boss, in order to make sure that you have minimal risk compared to maybe you're storing it somewhere in-house that doesn't encrypt it at rest in the first place and only has password and username protection, that may actually be a benefit for them. And say, hey, for this increased level of security, it will cost you this much. Okay.
Thank you.
Okay. And oh, by the way, there was one other story was somebody said, oh, we really need a cloud. Well, why do you need a cloud? We got 5 terabytes of data. Well, you know, a thumb drive can do 2 terabytes right now, okay? So, you know, I'm not sure that's the reason you need a cloud. Go ahead.
I have a variation of that question. What if you have 5 data centers and you want to consolidate them? Mm-hmm. What type of guidance do you provide?
Well, I mean, there are people who do this for a living. I'm not the type of person that people tend to come to say, do you do this or not? But usually in a case like that, if your 5 different data centers have the different formats, okay, so if you have 5 different types of relational databases and you want to combine them together, then putting them into a cloud format is actually not a bad idea. There is another project I know about that had like 1,000 databases, but every database was very small. Didn't matter. By putting them into a cloud, they put them all in the same format so that the 1,000 databases could talk to each other, okay, or be accessed all at once. So if you have like 5 data centers and you want to put them together, a cloud may be a good way to do that. If they're all 5 different data centers with the same data and all the same format, you might want to consolidate in a more traditional way. Not everybody needs a cloud, you know, but if there are things you want to do with that data you've never done before, like run MapReduce programs, look for correlations you never had a chance to do before, then you might want to do it. Again, it'll be more cost, but it may be worth it for the benefits you get of finding out what's in those 5 data centers. Okay.
Thank you.
To complement that, you could ask a series of questions to them
Yeah.
that are tied to the risk, and there may be some primary questions that eliminate many data center, many options right off the bat. So for example, if you have to have all data residing in CONUS, has to be handled by US personnel only, that eliminates a lot of choices. And then there's costs associated with that, and I think the speaker touched on a lot of those other things. So you could set up a filtering mechanism to help you think through part of the question. That's all.
We have a question up here. Hang on. Grab the.
Does each cloud provider offer each type of cloud? And let's say I start off with a utility cloud because I have a high analytic purpose, but ultimately my project will evolve into storage. Can I stay with that same cloud provider?
Okay, the first part of the question was, do all cloud service providers provide all types? And the answer is no. Some have niches, okay? Some focus on primarily like desktop as a service, for example, okay? So it just depends. In terms of most of the cloud service providers that have utility clouds also have storage, okay? So they can do that. Not all of them have the data focused, which is on the bare metal, the HDFS, parallel processing, and things of that nature. Now, the biggies have them all, okay? So Amazon, Azure, IBM, et cetera, they all have full service. They do all the above. Some of the more niche cloud service providers focus on niches because they got to compete somehow. Okay, that's one of the reasons they created the niches for themselves. Okay. Any other questions? All right. Well, thank you all. Leave that up there.